Hey, what's up guys? So in this video I'm going to be showing you how to create a complete two-dimensional platformer controller, and we're going to go over all the common practices in this video like coyote time, input buffering, and also things like wall jumping and wall sliding, fast falling, and basic movement with dashing. You can see the example I have right here demonstrates what I just explained. And this can be adjusted pretty easily and works very well for all 2D platformer instances. Quick note, we are going to use the entire video to kind of walk through and explain the entire setup, but if you'd like just the code, you can skip to the end, and there should be a timestamp there with just a full snippet of all the code that we use in the video. So to go ahead and get started, we're going to add a new scene at the top, and this is going to be our player node, so we're going to choose other node and search for character body 2D. We're going to also rename this to player. And I'm going to add a child node, which is going to be a sprite 2D. And for the texture, we're just going to use this player texture that I've created. I'm also going to zoom in and then just offset this a bit so that we are on the floor. And then as a child of the player, once again, I'm going to search for a collision shape 2D. We're going to add this and just define a new capsule shape in the shape property. Move this up a bit, and then simply adjust it to fill our entire sprite. I'm using a circular shape so that our corners react a little bit better with the world, and this way we can slide off of objects a little more realistically, and obviously this would look better if you have a proper character with animation set up. Now I'm going to save this really quick, so hit Control S, and we're going to go into our new folder, which I'm going to call player, and just save the scene inside of there. And then on the root node, which is the player character body 2D, we're going to add a script to this, and I'm going to save it in that same folder as player.gd. Once this is created, you can go ahead and open the script. Your editor might look something like this, where you have the built-in script editor, but I'm going to be using VS Code as I like the editing capabilities a bit more. And if you'd like to follow along in VS Code, you can check out the video, which should be in a card in the top right. So at the top of our player script, we're going to need a bunch of different properties, which are kind of going to act as values defining how the player moves. And I'm just going to paste all these values quick so that you can copy them a bit easier. So here are all the values that you're going to need just to find some constants for speed, acceleration, friction, and also the rest of them, which is stuff to do with gravity, stuff to do with jumping and wall jumping. After you've created these constants, we're going to need a few variables down here. So the first variable is going to be var input underscore buffer. This is going to be of type timer. The next one is going to be var coyote timer, and this is also going to be a timer type. And then our last variable is going to be var coyote jump available. This is going to be of type bool, and it will be set to true when we start the game. We're now going to scroll down a bit and add a ready function, so type function underscore ready, and inside of here we're going to set up our 2 timers when the game starts. Now optionally you can add these inside of your scene tree in Godot, but we're going to be adding them dynamically through code. So back in our script we're going to add a comment. This one will be first to setup input buffer timer, and inside of here we're going to say input underscore buffer is equal to timer.new. We're then going to set the wait time of this timer, so we're saying input buffer dot wait time. We're setting this equal to our input buffer patience, and this is going to be the constant which we define up here. So if you'd like to change the time that it takes to actually queue an input for jumping, then you change this value right here. And I'm going to explain this a bit more in depth later, but this timer is essentially going to activate when we don't have a jump available, and then within that time, if we do have a jump available at some point, then it will activate it automatically so that you don't have to always be exactly on the floor when jumping, but you'll have a bit of a grace period where the game will automatically jump for you once you hit the ground if you jumped too early. Now, obviously, when we set the wait time, we also want to set it to 1 shot, otherwise the timer is going to be looping. So we're going to say input underscore buffer dot 1 shot and set this equal to true. Now that we've created the timer, we simply need to add it to the scene tree. So type add child, and the child is going to be that input buffer timer. And then next up, we just need to set up our coyote timer as well. So we're doing the same thing, hashtag setup coyote timer. And inside of here, it's going to be basically the same code as we just did before, except we're going to say coyote timer and set this equal to timer.new. Then after we do that, we're setting the coyote timer dot wait time equal to coyote time. We're then going to set coyote timer dot one shot equal to true. And then after this, we want to make sure that we are adding the child coyote timer to the scene so that we can actually use it. And then we're also going to go one step further and connect our timeout of this timer to a method inside of the script. So we'll say coyote timer dot timeout, which is the signal that this timer emits when it has completed. And we're going to call connect on this timer and connect it to a new method, which we'll need to create, called coyote timeout. Now this method obviously needs to be created, so we're going to copy the name of this and scroll down in our script a bit and create a new function, paste that coyote timeout here. And inside of here, all we're doing is resetting our coyote jump when we time out. So we're going to say coyote jump available equals false. Now all of the setup so far might seem a bit confusing, but now that we've set up kind of the basic things that we'll need to use in our player logic, we can actually go ahead and get into the physics process, which is going to contain all of our movement and input mechanics. So in between these two methods, because I'm going to put this right under ready, we're going to define function underscore physics process. And then inside of here, we're going to first need to get the player input. So the first input is going to be var horizontal input, and this is going to be equal to input class dot get underscore axis, and the axis we're going to get is from the move left and move right input events. Now we also have to remember to set up these input events. So if you haven't done this yet, we're going to go back into Godot. We're going to go up to our project settings, and under the input map, I'm actually going to delete what I have right here. We're going to add some new actions. So the first new action is going to be move underscore left. Next action is move underscore right. And then we also need an action for jump. We need a dash action, and we need a fast underscore fall action. And then simply click the plus icon next to these actions to add the key that you want to activate this action. So for move left, we're going to do the left arrow, and we can also add A as a key. For the move right, the same thing, but the right arrow, and then we're going to add D as a key. For jumping, we're going to do up arrow or W. And then for dashing, it's going to be shift, and for fast fall, it's going to be down and also S. And the only thing you have to make sure of is that these names of the input actions are the exact same as the ones that we are using in the script. So for move left, I'm just going to check that there are no typos. Going back into my script here, make sure that move left and move right are the same as the actions that we just set up. Now, right after this, we're going to look for our jump input event. So we're going to say var jump underscore attempted, and this is going to be set to input dot is action just pressed. The action is going to be jump, making sure it's the same as the input event that we set up. After we've obtained the input from the user, we can now apply this based on what sides of the world that we're colliding with. So first of all, we're going to check if a jump was attempted. So we're going to say if jump attempted, and we also want to check if our input buffer time left is bigger than 0. And we're going to set up the input timer later, but essentially this is going to mean that if the player clicks the jump button and the timer has started, the timer is going to time out, but before it times out, if we touch the ground, then we're going to activate a jump either way. And this is so that, like I said before, in case you input a jump right before you hit the ground, you are going to still jump when you hit the ground, and it gives the player a little bit of leeway between inputting extremely accurate events, right? And this is common for most games, but basically to do this, we simply type or input buffer dot time left is greater than 0. And now we type the colon to enter this if statement, and we're going to do a quick branch here. So we're going to check first if our coyote jump is available. Then we're going to jump, and to jump we're just going to change our velocity dot y. We're going to set it equal to our jump velocity constant, and by changing our velocity, this is going to edit the internal velocity variable of our character body 2D, and we're going to move and slide at the end of the frame, which is actually going to use this motion. But for now, just setting our y velocity is going to actually apply the jump. And then after we do this, we want to make sure that we're setting coyote jump available equal to false, and this is so that our coyote jump will not activate simply by leaving the floor, but only by leaving the floor when we're not jumping. Next up, after this if statement, we're going to type elif and check if we are on the wall. So we're going to type is underscore on underscore wall, and horizontal input is not equal to 0. So this is going to check if we are on the wall. Then we are going to set our velocity.y equal to wall jump velocity, and this is again going to be our constant. And then we're going to set our velocity.x to push away from the wall, since this is going to be our wall jump mechanic. So velocity.x is going to be equal to wall jump pushback, and this is the value to actually push back off of the wall on the x-axis, and we want it to be dynamic, so we want it to push off of the opposite direction that we're moving into the wall by. So the way we can do this is simply multiply this value by negative sine of horizontal input, and this is going to return either a negative number or a positive number based on our left or right input. After this if statement, we're going to do one more, and this is going to be elif jump is attempted. And inside of here, this means that we did not actually successfully get a jump. So we are basically going to start our input buffer timer by calling input buffer dot start. And we don't need to define a time, because if you remember up here, we already set our input buffer wait time equal to the input buffer patience. So if you want to change the time of this, you would change your input buffer patience constant, which is currently 0.1. So this big block here is going to handle our jump, and it's good to add code comments. So we're just going to comment this, which is handle jumping. And then after this block, we're going to define a new part, which is basically going to check if we are jumping. Then if we let go of the jump key, we're going to fall a bit faster. And this is going to implement the mechanic of the longer you hold the jump key, the higher you jump. And there are obviously a ton of ways to do this, but the most common one is if input dot is action just released, and the action we're looking for is jump. And we want to check two conditions, so we're going to type and velocity dot y is smaller than 0, means we're moving upward. Then our velocity that y needs to be set equal to our jump velocity constant divided by 4. And this divided by 4 is basically slashing our y velocity and reducing it by that amount, right? And after we've handled setting our jumping velocity, we need to basically apply our gravity. After this if statement, we're going to add a new block of code, which is going to check if is on floor. Then we are going to set our coyote jump available equal to true. And we are also going to stop our coyote timer just so that we don't run into any bugs. We're next going to type else, which means we will not be on the floor inside of here. We're going to check if our coyote jump is available, and if coyote timer dot is stopped, which means that we are off the floor, our jump is available, and the coyote timer has not started yet. Then we want to make sure we start the coyote timer. And this will account for, once again, if we slide off of an edge and the player would like to jump, we're just adding a very small window where even if you're off the edge after a platform, you can still jump. We also want to, if we're not on the floor, change our velocity by the appropriate gravity, and there's going to be a different gravity value depending on if we are jumping, if we are falling, if we are wall sliding, etc. So basically we're going to set velocity.y, and we're going to say plus equals because we're changing our velocity by gravity, and we're going to use this new method which is going to be called get gravity, and inside of here we just need to pass in our horizontal input, and then outside of this method we're going to multiply it by delta. And obviously our get gravity method hasn't actually been defined yet, so we're going to do that really quick before we finish off the script. So copy our get gravity name, go down by our coyote timeout function, and we're going to make another new function, so call this one function, paste the get gravity, and inside of here we're going to require one argument. It's going to be called input direction. This is going to be of type float, and the default value will be 0. And this entire method is going to return a float. And inside of this, first we will check if our input dot is action pressed, and the action we're looking for is fast fall. And again, you do not have to implement fast falling, but I thought it was a pretty common thing to add to this video. Inside of here though, we just return our fast fall gravity. and this is a constant we defined at the top. Outside of this if statement, we're also going to check if is on wall only, and our velocity dot y is bigger than 0, and then one more and our input direction is not equal to 0. So this is essentially checking if we are sliding on the wall, and if we are, we're going to return wall gravity. And then the last line is going to be making sure that we return gravity if our velocity dot y is smaller than 0, else we're just going to return fall gravity. So now when we apply our get gravity to our y velocity, we're going to apply a different gravity value based on the current state of the player, and then obviously make sure to multiply this by delta. And if you want to change these values, again, it's just the constants at the top for these 4 different types of gravity. Now back inside of our physics process function, we're going to add another code block, and this is just going to handle our horizontal motion. So after we get the is on floor stuff, we're going to define a new variable. This is going to be called floor damping. And usually I don't see a lot of people implement this, but I think it's a pretty common thing that should be implemented. And this is essentially applying a friction if you are sliding on the floor. And if you are sliding through the air, we're going to have a lower friction amount. And to do this, we're basically going to set the type equal to a float, but the variable is going to be set to 1.0. And we're going to set it to 1.0 if is on floor. Then we're going to say else, set it to 0.2, and this will be 0.2 if we're not on the floor. We're also going to add a dash multiplier, which is going to be implemented with our dash key, which we set up. So to do this, define another new variable called dash multiplier. This is going to be of a type float, and we're going to set it to 2.0 if the dash input is pressed. So again, if input dot is action pressed dash, else it will be set to 1.0. Next up, we just check if we are inputting any horizontal movement. So we check if horizontal input, then we will say velocity dot x is equal to move toward velocity dot x horizontal input multiplied by our speed constant, also multiplied by our dash multiplier. And then we're also going to put in our acceleration multiplied by delta. And this one's kind of a long line, so I'm going to hide this quick. But so we're just moving towards our max speed according to our dash multiplier and speed, and we're moving towards this at the rate of our acceleration multiplied by delta. But if we're not inputting anything horizontally, which is going to be back here, we're going to type else. Then we want to do the same thing, but we're going to move towards 0. So I'm going to copy this entire line here, paste it down here, and then instead of moving towards our horizontal input times speed times dash multiplier, we're going to simply move towards 0. And then instead of the rate being acceleration times delta, we're going to replace this with friction times delta, and then we're going to put this entire thing inside of brackets, and we're also going to multiply that output by our floor damping. Now, the final thing that we need to add to this script is actually applying the velocity that we've been manipulating. So at the very end of this physics process, we're going to call the move and slide and make sure this is at the base level and not inside any of these statements. And if we click Control S, then this should work properly. So let's go ahead and instance our player scene in Godot. I'm going to go into my world, and I've just set up a ton of polygons that have static body 2Ds, but I've made an entities node, and as a child of this, I'm just going to instance my player.tscn, and then I'm also going to add a child camera to this. And in the camera, I'm going to enable position smoothing, and I'm going to set the zoom just to zoom in a bit. So we're going to say 1.5, save this, move the player up here, and then I can test this out. You can see that we can move around, we can jump. The longer we press the jump key, the higher we're going to jump. All the collisions seem to be working correctly, and then we can also wall jump. And if we move into a wall, we should be able to slide on the wall, which will slow down our movement. We also have dashing implemented, so if you hold down shift, you can go faster, and everything seems to be working correctly. Now, if for some reason your script isn't working correctly, I have pasted the entire code in the comments, so you can scroll down and copy that. Also, you can check the image that should be popping up right here, and that's going to give you just kind of a full outline of all the code we walked through. Additionally, if you want to learn how to push objects dynamically with this 2D platformer character, you can go check out the video which I've linked in the card in the top right here, and that's going to show you how to dynamically push rigid body 2Ds inside of your 2D platformer game, and it's going to give you a lot of tips for that. But that's going to wrap up the video, so if you did enjoy it or learned anything new, make sure to leave a like and also consider subscribing, as it does boost the algorithm a ton and help new Godot learners get access to this information a lot more easily, and also supports the channel. You can also check out some of the links in the description for various things, and also a link to the Discord server where you can get help on Godot specific or game development related topics. But anyways, hope you guys have a good week, and I will see you in the next one. Bye.